Hey guys, so today we'll be looking at 5D, which is a bit different to 5B and 5C. Again, we'll be using recurrence relations, but this time instead of using it to model simple interest problems, we'll be using it to model compound interest problems, as well as reducing balance depreciation, which is essentially compound interest, but we're decreasing in value over time. So we'll be looking at some contextual problems where things are reducing over time. Via compound interest, via compounding periods. So let's get straight into it. Keep the video nice and short. Make sure you got your heading. That's recurrence relations can model Alright, so we've got a slightly different formula to simple interest. It's very similar to the compound interest formula that you would have seen before, just looking more in the terminology of recurrence relations. So we still have an initial term. Represented by V0, so that's the initial or the principal, initial amount invested or borrowed. And then we have the Vn plus 1. Kind of looks a little bit like the compound interest formula. Alright, so VO represents the initial investment or amount borrowed. Vn plus 1 equals, within brackets, 1 plus whatever the rate is over 100. And then that's multiplied by the previous term to get the next term. So if we have a look at we'll do a problem. Down here is a bit easier. So let's say we got, that doesn't work. $800. We'll say 5% per annum. Now you notice with this one it doesn't have a time period or anything. Sometimes the questions will be, say, after the second or third compounding period. But just for now, we're going to establish the recurrence relation and then show how we can solve problems with it. Now, it's pretty straightforward. We don't have to solve really anything. It's just putting the two values in, the 800 and the 5%. That's all it is. So we've got an initial investment of 800. Our recurrence relation, Vn plus 1, is equal to 1 plus whatever the rate is, in this case 5, over 100 multiplied by Vn, or the previous term. So if we want to find V1, for example, alright, V1, we would go, okay, 1 plus 5 over 100 multiplied by the previous term, which is 800. So if my maths is any good, that will be 840. Work it out, V2. Plus 5 over 100 multiplied by the previous term, in this case 840. That will come out to 882. So a bit different to simple interest where you're adding the same value on every time. Compound interest changes because the principal is always changing. All right, the next part is reducing balance depreciation. So a similar idea, however this time we are decreasing in value. Formula for this one is slightly different, so we are going to do a little bit more work. Alright, I'm just going straight into the formula for this one. Same idea, we have an initial. So normally this is looking at the value of something. So the value of an asset could be the value of a car, losing value over time. And then the recurrence relation, Vn plus 1. And this one's going to look like this. Alright, so this one's a bit different. We have R multiplied by Vn. Now it's annoying that we use the letter R, but we just do, because it doesn't stand for rate. It's like the ratio, what it's going up or what it's going down by. Now to calculate R, we've got a little formula for that. Alright, 1 minus the rate over 100. It's essentially what we had over here within the bracket, but just subtracting. So let's say we'll do another example. Let's say computer. For $2,000. Decreases with reducing balance depreciation. Again, we'll go 5%, that's easy, per annum. One thing I forgot to mention, and I'll say it before I forget, with the compound interest formula, if you've got non-annual compounding, like we had in the previous topic, it's the same sort of idea, you just adjust that denominator, all right? So if it's a monthly, you make that 1,200, weekly, 5,200, fortnightly, 2,600, daily, 36,500. If you can't remember what to change the denominator to based off your compounding periods, just check your notes from financial arithmetic. It's all the same. Okay, so with this one, let's calculate this R value here first. So R is equal to 1 minus whatever the rate is over 100. Alright, you can do that in your head on a calculator or whatever. We'll come out to 0.95. What that 0.95 means is, because it's losing 5% of its value every year, that means it's retaining 95% of its value each year. So it's losing 5, but keeping the remaining 95. That's what that 0.95 is doing. So then to write in the recurrence relation, V0 being the initial cost of $2,000, Vn plus 1 equals that R value we worked out, 0.95 multiplied by the previous term of Vn. And that's our recurrence relation. So for example, we wanted to calculate V1, simply be 0.95 multiplied by the previous term of 2,000. 0.95 times 2,000 will give you 1,900. V2, all right, take 0.95, multiply it by the previous term of 1,900, or gives you 1,805. So after 2 years, the computer, based off this, is worth $1,805. That's essentially it for this exercise. Like per normal, some of the questions get a bit more complex, but the underlying skills are the exact same. Remember, it's always a good idea to check the more worded examples within the textbook. So have a look at the worked examples before having a go at each of the questions. Thanks, guys.